Today we're going to talk about the division of polynomials. And there's two types of divisions we do on polynomials. The first one is long division, as illustrated in this problem that we'll discuss later. And synthetic division, illustrated a different method here. Synthetic division is a special type of division that we can only do at certain times. But it's certainly a very easy type of division to do. Before we actually do some division with polynomials, let's first talk about what it looks like when we divide whole numbers, because that will give us an idea of how we'll write our answers and the names that we'll give to different pieces. In this first example that we're going to look at, we see that we have the division problem 10 divided by 5. Now sometimes, and many times, in fact most of the time, that problem in college is written as a fraction style, 10 divided by 5. And of course we know the result of this division is 2, so 10 divided by 5 is equal to 2. Now when we think of 10 divided by 5 as a fraction, we call the top the numerator and the bottom the denominator. But when we're thinking of it as a division problem, then we call the top the dividend. So this 10 is called the dividend. And the bottom is called the divisor. So in this case, the 5 is the divisor. And then the quotient, that is the result of the division, is called the quotient. Now in this particular problem, the division has no remainder, so we might say the remainder is 0. But it doesn't apply in this problem. Now we can remember from years ago, when we had problems of this type, we would check our work by saying 5 times 2 is equal to 10. And you recognize that 5 is the divisor, 2 is the quotient, and 10 is the dividend. So we can check a problem of this type using this idea of divisor, in this case 5, times quotient, in this case 2, and we want to be very sure that that gives us the result of what we divided into, in this case 10, which is the dividend. If we don't get that dividend, then we've made an error in our division. This time I'd like to look at a division problem of whole numbers in which we actually have a remainder other than 0. So suppose we have a problem that's presented 19 divided by 5. And as we mentioned a moment ago, we understand that most of the time that's probably given to us in the form of a fraction, 19 divided by 5. Here again we see that 5 will go into 19 3 times whole, but there will be a remainder of 4. And so we're used to writing this in the form 3 and 4/5. 3 and 4/5. Now the problem is that when we're dealing with polynomials, we don't have this idea of mixed numbers. But 3 and 4/5, although we don't write it this way, we understand it's 3 whole units plus 4/5 of a unit. So it really is the same as 3 plus 4/5. And this is a form that we can imitate when we're dealing with polynomials. So let's once again understand that our situation here, the top number 19 is called the dividend, and the bottom number 5 is called the remainder. Now in this case we get the quotient, the 3, so as we write our answer we'll say the quotient plus the top number here is the remainder, and of course the bottom number once again is the divisor. So quotient plus remainder divided by divisor is the way we would write our answer. Now in this case, if we kind of recall from a long time ago, the way we check a division of this type, and before I do that, let's write it out as a division problem with a long division symbol. That we might remember that we would do something that might look like this, as we begin to start that division. And then we would have said it goes into 5 goes into 19 three times, and then 3 times 5 of course is 15. We write down our 15 and we get our remainder of 4. And so those are where those pieces come from. Now when we're checking a problem like this, if we recall, we would say, oh, 5 times 3 plus 4 must be equal to 19. 5, which is the divisor. So the divisor times 3, which is the quotient, plus the remainder, which is 4, is supposed to result in 19, what we have here, which is the dividend. And we see, of course, it does, and so we know we're correct when we have done this, doing this long division. So again, this is another expression that we're going to be able to use when we talk about polynomial division. If we want to check our polynomial division, we take the divisor, the polynomial divisor, we multiply it with the polynomial coefficient, we add the polynomial remainder, and we better get the polynomial dividend or we've made an error. Divisor times quotient plus remainder better be equal to the dividend. Well, we're ready now to actually do some division of polynomials.